Now we will look at Newton's second law of motion. If an unbalanced force acts on a body, the body will experience an acceleration of A. That is, firstly, proportional to the unbalanced force acting on it. Secondly, inversely proportional to the mass of the body. So how can we present that? The first point is proportional to the unbalanced force. A is proportional to F, which means that if you have a larger force, you will get a larger acceleration. You double the force, you double the acceleration. Proportionality. The second point is it's inversely proportional to the mass of the body. So there's an inverse relationship here. If you have an object which is more massive, it's going to be harder to get it to accelerate with the same force. So we can present this as A is proportional to 1 over m. So there's equation 1 and equation 2. If we combine the two of them, we say A is proportional to F and 1 over m together. This can be, we can get rid of the proportionality sign by getting constant in there. A is equal to K F over m. But we define 1 Newton as that unbalanced force that makes 1 kilogram experience an acceleration of 1 meter per second squared. So if this is 1 and this is 1 and this is 1, that defines 1 Newton. So K will be equal to 1 as well. So we can ignore this constant. A is equal to F over m. The way we remember it is F is equal to ma. Just rearranging this. But by Newton's second law, it's easiest remembered by F equals ma. We have a problem here. The mass is 500 grams. There's a force pulling to the right, 12 newtons, force pulling to the left of 6 newtons. So you have to find out what is going to be the acceleration. Pause. Notice that here it says to the right, because acceleration has direction. Acceleration is a vector. Here we have another problem. This is a 10 kilogram weight. The scale reads 12 kilograms, which means it must be accelerating upwards. What is the acceleration? Use F is equal to ma. F is the unbalanced force acting on the sack of potatoes. Here's another question that you need to read and answer. Pause. 2 blocks having different masses slide down a friction slope. Pause. Here we have a weight which is dropping onto a top pan balance. Notice when the weight is sitting on here, the weight will be W, it would read W, but it's colliding with it, so that makes it kind of easy to answer that. Here we have, we want to find out what the acceleration is, but the force must be in the direction that the acceleration is, so you need to find the horizontal component of the force to find out what acceleration. Here's another problem here. We have 2 masses, there's a tension in each pulling up, and there will be acceleration. So you need to basically find out what is the tension in the string when the masses are accelerating. And this is a similar kind of question. You just take the tension here and tension there, do F is equal to ma for this side, and each will have a term of t in, and then you will cancel t to find the acceleration.